Okay, hydrolysis. Hydrolysis mean that is the combination of hydro and lysis. Hydrolysis mean hydro mean water and lysis mean to break down. So when water molecule break any other molecule, so break down by the water you can say. Water itself break into two pieces and it break the other molecule as well. So whenever, generally speaking, whenever whenever you are going to break CO bond, whenever you are going to break CN bond, whenever you are going to break any CF, Cl, CBr bond. So whenever, especially, at least you will have to revise, memorize these three type of molecules and their bond. Whenever you are going to break CF bond, CO bond, CN bond, then what is the next step? If you are going to have carbon with OH, if you are having OH group instead, let me change it once again. If you are going to have OH group over here with the carbon, so if you are going to break these bond, if the polar bond with the carbon is broken, especially I'm going to talk about hydrolysis in organic chemistry, not in inorganic chemistry. In organic chemistry, these are basically the major famous bonds: CN bond, CO bond, C halogen bond. When these bonds are broken and there is introduction of OH, COH group, there is introduction of OH bond, OH group on the carbon atom, then it is said to be hydrolysis. In fact, what is happening over here? Hydrolysis is happening over here. So what to do hydrolysis? How to do hydrolysis? What are the basic conditions? There are the two basic conditions. Number one, we can use acid during the course of hydrolysis. That is called acidic hydrolysis. Acidic hydrolysis. If I'm going to use OH negative ion, aqueous, it's also in form of aqueous. So if I'm going to use H positive ion aqueous, I'm going to remove these brackets. This is called acidic hydrolysis. If I'm going to use OH negative ion aqueous, it is going to be alkaline hydrolysis. This is called alkali, alkaline hydrolysis. So what they are doing basically, what is their function? This OH negative ion and H positive ion, they are going to act as catalyst. This H positive ion is again going to act as catalyst. So we can use as a dilute H2SO4, and the condition is heat. So whenever we are going to perform acidic hydrolysis, we will use dilute sulfuric acid, and we will do the heat. So whenever any molecule that is having CO bond, CF bond, CN bond, so these bonds will be broken. Usually single bonds are going to be broken. If there is no single bond, then double bond or triple bond can be broken. So whenever we are going to break a bond with the help of water molecule, basically water is going to break this bond with the help of acid, with the help of alkali. If you are using acid, this is called acidic hydrolysis. If you are going to use alkali, it is called alkaline hydrolysis. Now, if you are using acidic hydrolysis and they are asking to write the reagent and conditions, then you will write dilute sulfuric acid and heat. Now I'm going to explain the different examples. Those are in your AS chemistry level. Number one, the first thing, that is ester. You can hydrolyze ester. This is the ester for example, this is methyl methanoate. So what is happening? Where bond is supposed to be broken, this bond will be broken. This CO bond, not this one bond. This CO bond will be broken because this carbon is having two oxygen atoms, and these two oxygen atoms are highly electronegative oxygen atoms. So this CO bond is broken. I mean, this is the more polar bond. It will be broken. And what will be done next? The next phase is, generally speaking, this carbon is going to attach, going to have OH group, as I told you over here. This carbon that, broke its bond. The bond is broken from C single bond O over here, and OH group is going to attach with this carbon atom. Now the OH, what happened to this O? Is this O is going to have hydrogen atom. I mean, this is the water. Water break its bond as well. One is H, other one portion group is OH group. So OH group is going to attach with the carbon, this C double bond O, and hydrogen is going to attach with this oxygen. So finally, if I'm going to write it over here, I'm going to write H2O in form of a balanced chemical equation. And what is the answer? The answer is HC double bond OH. OH, this one. And plus, I will write CH3OH. So this is an acidic group that is called methanoic acid. It's called methanoic acid, and it's called methanol. Now, as you know, we are using basically an acidic solution as a catalyst. So these products may react with this catalyst. So let me check once again. Step number 2, you will check either they are going to react with H positive ion or not. So this one, this carboxylic acid and methanol, they are going to, are they reacting with H positive ion? No. These both are acid and they are not going to react with each other. Same is the case ethanol or any alcohol. No one alcohol is supposed to react with any H positive ion or OH negative ion. So this one is the basic general, equation and the product. Now come towards, I'm going to write another compound that can be once again hydrolyzed. It is called amide. This is said to be amide, and its name is ethanamide. Ethanamide. And yes, it also can be hydrolyzed by reacting with water, H and OH. Again, this bond is broken down, C single bond N is broken down. As I told you, you can break C single bond N. So what will happen? This carbon will be having, in case of again H positive ion, aqueous H positive ion, and what will be the product? Ci3, C double bond O, and I will write OH with this carbon. Plus, this hydrogen will be given to this molecule. So NH2 plus 1 hydrogen, that is called NH3. Now the second step, what is the second step? The second step is we will check either it can react with the catalyst. No. Can this react with the catalyst? Answer is yes. So it's a base. NH3 is a base. This is the acid. So NH3 will react with the base, and there is NH3, no NH3, there will be NH4. There will be no NH3, there will be NH4 positive ion. So NH4, you are not allowed to write NH3, you will write NH4 positive ion aqueous. So this is, the final step. There are basically 2 steps and so on. First, I told you how to hydrolyze the ester. That was how to hydrolyze an amide. Now I am going to show you how to hydrolyze this nitrile. This is called ethane nitrile. Ethane nitrile. It's a little bit special, you can say. The different, it's going to make the different product with respect to the others. Once again, I'm going to add water, H, OH, and now this time there is no single bond. There is only one polar bond, that is CN, but this is a triple bond. So all bond will be broken, triple bonds. This whole group of three bonds, triple bond is broken down. And now this carbon is changing itself into, basically, it will get Ci3, it will get OH group with it, OH group with it, and this nitrogen will be having hydrogen with it. So, but here is a problem, that any carbon that is having two or more than two OH group is said to be unstable carbon. It cannot sustain more than one OH group. So two OH group even cannot be attached with a single carbon. So there is a rearrangement of the reaction. There is a rearrangement of the reaction, and here is removal of H2O from here, and rest of the molecule will be there. So what is going to be formed? An acid is supposed to be formed. Ca3C, there will be double bond OOH. An acid is supposed to be formed, plus H2O again. I mean, an other molecule H2O be formed. There is no need to write H2O because we are going to add S as a reactant. So there is no need to write H2O. But how to write? And the next one is we are going to attach three hydrogen atom. So NH, first of all, I'm going to write NH3. So one acid is going to be formed. The second one is NH3 is supposed to be formed. Whenever you are going to hydrolyze nitrile, it's a special case. It's a special case. Whenever you are going to hydrolyze the nitrile, whole carbon triple bond is broken down. Next thing, this carbon change into acidic group, carboxylic group. This carbon shift into, transform into, change into carboxylic group, and this nitrogen changes into NH3 group, amino group, NH3 group. So once again, if I'm using H positive ion aqueous catalyst, then I will check its reaction with acid, no reaction. I will start checking this its reaction with NH3. Yes, it will do, and it will make NH4 positive ion. So I will write NH4 positive ion. Now the next example that you should know of hydrolysis is the fourth one. At least you know about these four examples: CH3 and CH2Cl. There is another one as well, fifth one, but I think it's not in your syllabus now. However, we will discuss it as well. So if I'm going to add H2O in this haloalkane, it's called chloroethane. So what is going to be formed? Once again, this CCl bond is broken down. This is basically CCl bond, and again this carbon is going to have OH group. So alcohol is going to be formed in this case. In this case, alcohol, not the acid, alcohol is going to be formed, plus this H and this Cl will meet together to make HCl. Again, in the presence of H positive ion aqueous, there is no reaction between acid, there is no reaction between alcohol and acid, so it will remain unchanged. And in all these conditions, as I told you, we will heat throughout the reaction mixture. So every time we should write acid plus heat, and it's heat, and here heat. Now the next thing is, in this case, if I'm going to add into the water, then there is no need of catalyst, no need of heat. It's a highly rapid reaction. It's an exothermic reaction, and it is rapid reaction, fast reaction, I mean. So what is happening? This group is going to be broken once again. CCl bond is broken down. Single bond and polar bond preferably. And this carbon is going to have OH group. So it is going to be formed Ci3 OH acyl group, plus H and Cl will meet together to make HCl aqueous. So these both compounds are aqueous, I mean. And in this case, especially, this is also one of the special case, you can say, there is no need to apply any conditions. There is no need to add any catalyst. There is no need to heat the reaction mixture as well. So these are at least overall, 5 group that can be, those can be hydrolyzed in organic chemistry, whatsoever is the medium. I'm going to repeat one example more once again, with in the presence of alkali. For example, I'm going to once again going to hydrolyze this ester, HC double bond OCH3. This time I'm in water, but in the presence of, let's suppose, sodium hydroxide. Hydroxide plus heat, and it is aqueous heat. So what will happen? Again, this bond is broken down. Single polar bond. If there is no single polar bond, then obviously double polar bond or triple covalent, but polar bond. Polar bond when the carbon is making the bond with any other element other than hydrogen. So it's a polar bond, it is least polar bond, or it is not supposed to be the polar bond. So this bond is broken down, and we are going to have this C double bond, and here I am going to use OH group, this one, and this one is going to have H group, obviously. So basically CH3OH group is over here. Now what is step 2? Step 2 is, let me check, either it can react with this catalyst. Yes, it can react. It is an acid and it's a base. So what should be its form? I am going to write it over here as a rough work. This acid, when it reacts with NaOH and AOH, it is going to make salt and water. So HC double bond O N A. This H and OH will be lost making water, and Na will be over here. So this is called sodium methanoate. So here I'm going to write ONA. Here ONA. So you are not allowed to write this acid over here. You are not allowed to write the formula of acid. Now you will make salt, because they will react with each other, and definitely the acid that has been formed, it will change itself into salt. So let's see over here, we have made the 2 species. Again, this alcohol, the second one, and it is not supposed to react with NaOH. It will not react with NaOH, and the simple that there was the acid that is going to react with the NaOH. So the step number 1, to break the polar bonds on your page, on your rough work, then attach OH group with this carbon. The main group is the carbon over here, and this carbon, and the other one atom that is being departed from here, it will gain hydrogen. So every time you will repeat the same whole procedure, similar procedure. But in case of ethane nitrile or any other nitrile, you will break this triple bond, and this carbon will be changed into acidic group, and this N will be changed into NH3 first of all. Then you will check what is the condition. Basically, if you are going to use acid or if you are going to use alkali, then try to check whether both of them or any one of them can react with this medium, with this catalyst. If they are reacting, then change their formula, and so on. So this is the final product that you are supposed to write over there, so as to get full marks. So that is all about hydrolysis. You can write all these equations with NaOH or OH negative ion, and so on. Got